Okay, hello. This is the practice problems part of the chapter 3 section. So I've gotten one question, two questions, and then over here we've got four more questions. So six questions total for this video so that what we're doing can be learned. So a race car C travels around the horizontal circular track that has a radius of 300 feet. Okay, so that's rho. Keep that in mind. If the car increases its speed at a constant rate of 7 feet per second squared, okay, that's acceleration. Starting from rest, v naught equals 0. Determine the time needed for it to reach an acceleration of 8 feet per second. What is its speed at this instant, right? So we'll go back over here. We're doing Q1, which is on this one right here. Okay, so what do we know? We have a squared equals at squared plus a naught squared, right? And we can transform this right here to be v over rho squared. V squared over rho squared, like that, right? What we know is that at is 7 feet per second squared, okay, initially. And we're looking for when it becomes 8 feet per second squared. So we also need the time and the velocity. See, time and not velocity, speed. So we know that we want it to be 8. We want our acceleration to be 8. Okay. We know our tangential acceleration. And okay, this is the distinction you need to make here. Because it says determine the time needed for it to reach an acceleration of 8 feet per second squared. Now you might be thinking this is tangential acceleration, but now we need to be thinking, and it's on the diagram as well, but now we need to be thinking of this acceleration here, not this one, because this is only one component of acceleration. This is the other component. Come together, they make this component. So if it specifically mentions tangential acceleration of 8, then you would do it like that, right? But it wants just acceleration, so we need to use this. We set 8 squared equals 7 squared plus v to the 4 over rho, which is 300 squared, just like that. Okay? And then now we just rearrange. We put it into the calculator. So 8 squared over 7 or minus 7 squared. 8 squared minus 7 squared times 300 squared. And then we take the fourth root, which gives us a velocity of, let me write that, v equals 34.1 feet per second. That's not velocity, speed, sorry. Okay. And we need the time as well. So, okay, that one's pretty straightforward. We will just use a kinematics equation for that. So we can look at our formula. You can look at your formula sheet. I'm not going to. We're going to use v equals v naught plus a t squared. At. And keep in mind, this is like tangential acceleration because the tangential acceleration is constant, not the total acceleration. Okay, so we have that our final velocity is what we just calculated, 34.1. Our initial is 0 because remember it starts from rest. Our tangential acceleration is 7, and we're solving for time. So it's just going to be 34.1 divided by 7, which gives us a time of 4.87 seconds. And that's the question. That's all there is to it. That one's really easy. Very straightforward. Shouldn't have a worry about that. So let's go as Q2. And Q2 I have here is this diagram. Okay, this is really blurry, so I apologize for that. The X and Y motions of guides A and B with right angle slots control the curvilinear motion of the connecting pin P, which slides in both slots for a short interval. The motions are governed by x equals 20 plus a quarter t squared and y equals 15 minus a sixth t cubed, where x and y are in millimeters and t's in seconds. Calculate the magnitudes of the velocity and acceleration of the pin for t equals 2 seconds. Sketch the direction of the path and indicate its curvature for this instant. Okay. Easy. I'm going to skip the sketching part because I don't want to sketch. You can sketch it if you'd like, but it should be pretty straightforward. Okay, so we're looking at x, first of all. So we have that x as a function of t is equal to 20 plus a quarter t squared. I should get a hotkey for fractions. You know, that would actually be pretty smart. And as we already know from previous things, we just take derivatives to get our acceleration and velocity. So we got a half t, and then a of t is just going to be a half. Right? And then we'll move on to y. We have y of t is equal to 15 minus 1 over 6 t cubed. And then v of t is equal to negative 1 or negative 1/2 t squared. And then a of t is equal to negative t. I don't know why I stumbled upon that. Anyways, we want the magnitude of velocity and acceleration at t equals 2 seconds. So t equals 2 seconds. And remember, magnitude is denoted like this. It's equal to the square root of vx squared plus vy squared. And same thing for acceleration, just with acceleration, obviously. So we plug in t equals 2 for velocity. We're going to get that vx equals 1 and vy is equal to negative 2. Because 2 squared, 4 over 2, yeah. So there we go. And then now we plug it into this equation. Magnitude of v is equal to the square root of, it's going to be 1 plus 4, so root 5. There you go. Simplify, I mean, like actually calculate this if you want. I'm going to keep it as root 5 because that's a bunch of decimals to write out. No need for that. Anyways, now we move on to acceleration. So we have ax is equal to a half. That's constant. And then ay is equal to negative 2, right? So now we're just going to go magnitude of a is equal to square root of a half squared, so a quarter plus 4. So 4 is 16 quarters, so 17 over 4 quarters, like that. Square root of 17 over 4. Yeah, that's correct. And then remember, there's the sketch the path and indicate its curvature for this instant. You can do that. I'm not going to do that because, yeah, I don't want to do that. Okay, next question. A boy throws a ball upward with a speed of v0 equals 12 meters per second. The wind imparts a horizontal acceleration of 4.4 meters squared to the left. At what angle, theta, must the ball be thrown so that it returns to the point of release? Assume that the wind does not affect the vertical motion. Okay, so basically it's saying this guy is throwing it like this, but what angle can he throw it at so that the ball will just come back into his hand? And it's saying the vertical motion is just going to be like this. We assume it's a straight line. We want it to go this way, basically, after his throw. Or this way, depending what the angle is. Theta is here. Yeah. Okay, on to the calculation stuff. So, we're on to Q3. Let's get out our terms. We have that V0 is equal to 12 meters per second. We have AY equals to negative 9.81. 9.81. We have that AX equals 0. I mean, sorry, not 0. There's wind. Negative 0.4. And I'm going to quickly... These are my... This is my positive. This is what I'm defining as positive. These directions. So up and right are positive. That's why both my accelerations are negative. Meters per second squared and meters per second squared. What else do we have? That's all the info we have. Okay. So we'll start with x, and this is how I like to do like these projectile motion questions, is splitting into x and y. You don't always have to do it though. Like, I mean, like writing it visually, splitting it as x and y. You don't always have to do it. Honestly, I forget most of the time to like actually write a lot of stuff. So all my work can seem like rambling sometimes, but that's fine. We're gonna use our kinematic equations, right? And we're solving for theta here. And we need to keep in mind that the ball might be moving this way, but we're assuming it returns straight back because we want to find theta for this to happen. So that means that the final and initial position is going to be 0, right? It's going to be 0. And also v of x, if we look here, sine is defined, I mean, theta is defined like this. So if we make a triangle, this is a wall, not hypotenuse, like this. If we make this our triangle, right, we're going to have sine, I can't really tell actually, but it's going to be a sine term. So Vx is going to be 12 because that's the velocity. 12 sine theta, right? And then we have Ax. So we'll look at our equations and we'll use the one, we're looking for the time, I believe. Yeah, we're looking for the time because that's the only thing we can solve for. Because we know S and S naught. So looking for the time, which we get our equation, it's going to be 0 equals 12 sine theta t minus, and this is in the x direction, keep in mind, it's a half a, so a half of 0.4, 0.2 t squared. And we're just going to set these equal to each other because why not, you know? 12 sine theta t equals 0.2 t squared. Just like that. And you can cancel the t's if you'd like, right? That doesn't change anything. So it's just going to be like this. That's just going to be like this. Now you're probably wondering why we do this, right? And it's because one of the ways we can get theta is by using tangent, right? Because tan is sine over theta. Sine over cos, not sine over theta. Sine over cos. So if we have some sine equal something, some cos equal something, we can then get a formula for tan. And we have what's equal to sine divided by what's equal to cos is equal to tan theta. Then we take the inverse of what is equal and it gives you theta, right? This is just basic trig stuff. You should know that already. Anyways, onto the y direction. I used the wrong slash here. That's kind of finicky. Okay, onto y. Vy is the same thing but cosine, so 12 cos theta. And again, we know that sy and sy naught are just 0, right? Because we're assuming we want it to return straight back to where it started. So it's completely just going to be zeroed out. We're going to use the same equation, which is going to be 0 equal, that's an O. 0 equals 12 cos theta t. And this is, now we're using 9.81 minus 4 point, what is it, 985, I think? I hope that's right. I haven't, off the top of my head, I don't know that. Whatever, that's fine. And then simplified 12 cos theta equals 4.985 t, right? And now, as you can see, we have two things that we can divide. So when we divide out, the 12s cancel, and we're going to get tan theta is equal to 0.2 over, also the t's will cancel here, as you can see, 4.985. And then we take the inverse tan, which gives us a final answer of theta equals, and let me just get this into the calculator. Theta equals 0.2 divided by 9.81 over 2. Okay, so we get a theta of 2.33 And I have degrees now on the hotkeys. So degrees. Very nice. That's that question. We got theta. If he wants the ball to come exactly right back into his hands from where he threw it, he has to throw at an angle of 2.33 degrees. And that's that. Okay. Next question. We got 3 more questions. A car travels along the level curved road with a speed which is decreasing at the constant rate of 0.6 meters each second. The speed of the car as it passes point A is 16 meters per second. Calculate the magnitude of the total acceleration of the car as it passes point B, which is 120 meters along the road from A. The radius of curvature of the road at B is 60 meters. Okay, so that's our information. Let's move on to it. This is Q4. Okay, so we know that the tangential acceleration is constant because it said so. Constant rate, right? So that means we have AT is equal to negative 0.6 meters per second squared, right? And we have AN is equal to V squared over, remember rho is 60 meters as mentioned. So there we have AN. And this is at point B, by the way. So let me just, point B. These are values at point B. We want the speed at point B. So we're solving for this V, basically. Yeah. We are solving for this V. We have the velocity at A. I mean the speed at A is 16 meters per second. Yeah. We want the magnitude of the total acceleration. Okay, yeah. We have the speed, which is 16 meters per second. We can use kinematics. Now, you might be wondering if that's allowed when you have a curved road, right? Because kinematics is usually like straight distance. Or you might be thinking, do I have to split this into straight components, right? No, you don't. No, you don't. Okay, that's not a straight line. Do I have a line tool? Okay, it doesn't work. Anyways, straight line. This is still 120 meters, right? Like along this line. So it's okay to do that. You can use your kinematics. Don't have to worry about any of the curved stuff, right? So final velocity is VB, initial velocity is VA. We have acceleration, and we have the distance, the difference in distance. We have S minus S naught. We just don't know like the initial and the final. So we have delta S, which is fine. That's what is in the question anyways. So we get that VB squared is equal to VA squared plus 2A delta S, right? Plug in our values, we get that VB is equal to the square root of VA 16, so 16 squared plus or minus 2, so negative 1.2 times 120, like so. And this gives us a VB that is equal to, let's just calculate this quickly, 16 squared minus 1.2 times 120. That gives us a velocity B of 10.6 meters per second. And now we need to find the magnitude of the acceleration, which we do pretty easily. We take our equation from here, our AN equation, and we plug in our velocity. So put 10.6 into this, and then 10.6 squared over 60 gives us a AN of 1.87 meters per second squared. And then the magnitude, of course, will just be A is equal to square root of negative 0.6 squared plus this. Okay, it's doing this again. I don't know why it's doing that. Plus 1.87 squared. Oh, maybe it's because there's a dot in it when you copy and paste. I think, okay. And then that gives us an A that is equal to 1.96 meters per second squared. And yeah, 1.96 meters per second squared. And that's that question. Okay, so 2 more questions now, the ones I have written down here. I forgot to separate these. So there we go, that's fine. Okay, so for this question, Let's read it. It says, a particle moves along the curvilinear path in the Cartesian coordinate system with velocity as this function 12ti minus 9tj plus 5k, t's in seconds. What is the magnitude of its acceleration when t equals 2 seconds? So to get the acceleration, we just take the derivative of this vector. So it's going to be 12i minus 9j plus 0k, right? And now we just plug in 2 seconds. Wait. This is supposed to be t squared. This is supposed to be t squared. Okay. 24t. There we go. So we have this. We plug in 2 seconds. So we get a of t is equal to 48i minus 9j. And to get the magnitude, of course, you just do the square root of the components squared. So square root, or here, magnitude equals square root of 48 squared plus negative 9 squared, which is equal to, let's just see, 48 squared plus 9 squared. 48.8 meters per second squared. So 48.8 meters per second squared. Right? That's part A done. Now on to part B. If the particle's location at t equals 0 is xyz 820, what are its coordinates when t equals 2 seconds? Right? So we need to integrate each of the components of the velocity thing to get our position vector. So the integral of 12t squared divided by is going to be 4t cubed. And we're going to have, this is a definite integral, by the way. Let me actually draw this out. So we're going to have this integral like this, s naught to s. S is what we're looking for. ds is equal to, and this is just like this. It's going to be 0 because time is 0 to t. It's going to be time 2, but that's fine. We'll just leave it like this. V of t, right? So we're going to be adding, these values to each of our integration parts when we're getting s of t. So s of t is equal to, it's going to be 4t cubed plus 8, right? Because it's when you integrate this right here, it's s minus s naught. So plus s naught for each term, I. And then minus 9 over 2t squared plus 2, j. And then plus 5tk, because it's just 0, so that doesn't matter, right? And now we just plug in t equals 0, so t equals 2 to this. So we're going to get 4 times 8 plus 8, which is 40. 4 plus 8 plus 8, so 40i minus, we're going to have 9 over 2t squared plus 2. Also, this minus is supposed to be on the plus like this. Minus 9 over 2t squared, so minus 9, 4. So it's going to be 9 times 2, negative 18 plus 2, so negative 16. So minus 16j, and then plus 10k. And that's the answer to that question. That's done. That's B. So as you can see, pretty straightforward question. It wasn't that difficult. They're just asking to do a derivative and plug in values, do an integration, plug in values. You need to know this definite integral though. S naught to s, right? Because we're getting position, and then time is 0 to t equals 2 seconds. If you get a question of this form, you're gonna have a definite integral. You need to watch out for that. Okay, but that's fairly obvious in my opinion. Okay, and then final question. I know it's on the other page, but it needs this diagram. And that website can't paste images, so I had to put it here. Okay, let's read it. At location A, a ball is kicked at an angle of theta A equals 30 degrees. Right? This is the wrong way. Above horizontal, which we can see right here. 30 degrees up, above horizontal. And then it hits the ground at location B. B is right here. The ground slopes downward, described by the equation y equals negative 0.12x squared as shown in the diagram. Where location A is the origin, the horizontal distance from A to B is x equals 5 meters. Horizontal distance. So this is a coordinate x equals 5, right? So we can get the y coordinate for this pretty easily, by the way. The horizontal, determine the initial speed, VA. Okay, so we're going to have to do some, I remember getting this question in a seminar. This was kind of an awful question. We had to do this weird rearrangement that, okay, it's not that weird, but I didn't intuitively think of it during the seminar, and none of my friends did either. I took it off a TA, or someone in my row took it off a TA, and then I took it off them. Okay, I'm rambling. That's not really relevant to the question. So we're gonna have to. This is projectile motion, so we're gonna be using kinematics equations, and let's start in x, right? So we're gonna use v equals d over t for this x, right? And we want t. So you wouldn't think we want t. We want initial speed, right? But the thing is, we don't even know what v is itself. This is VA, by the way. I should specify that. We don't know what VA is. We're in the horizontal direction, right? So we're just going to change this to VX. And what is VX? Right? VX is, if we look at this, the velocity in the x direction, adjacent, so cosine, is equal to VA cosine, and our angle is 30, right? So we're going to put that in there. So we have our distance, by the way. The total distance traveled is going to be 5. That's pretty obvious. Anyways, now let's just plug in the values. Sorry. Rearranging for t is equal to d of 5 over VA cosine 30, right? And then calculating this, if we do 5 over cosine 30, by the way, 5 over cosine of 30, we get, okay, don't do that. We get 5.77 over VA. And I'm just going to call it V for simplicity's sake. Right? That's our time. Now, we're going to be looking at the vertical component. And for the vertical component, that means we need the y coordinate at this point, right? So let's get it. So y of 5 is equal to negative 0.125 squared, which is equal to, so negative 0.12 times 25 is equal to negative 3. That's a clean number. I like that. Negative 3 meters down because it's vertical. Okay. With this, we can now use our kinematics equation where we have the distance stuff. So final position is negative 3. Initial position is 0. Initial velocity, we have Vy. If Vx is cosine, Vy is sine. That's how that works. So we have Va sine 30. And then acceleration, we're on Earth. We're assuming we're on Earth because, I mean, otherwise this question is impossible without this value. So it's minus 9.81 over 2, so 4.985 t squared. And I forgot to put a t here. Oh, that's a 6. Okay, that's our equation. Now, if you're noticing something, we have a VA here. We have a t here. Or I said I was just going to call this v, right? We can plug in t. From here, we can plug it into here. So let's do that. Negative 3. V's cancel. So it's just going to be 5.77 sine 30 minus 4.985. Okay. 5.77 over v squared. Now, this is not anything crazy. You can rearrange for v is going to be, it's going to be a square root term. But then once you calculate it, you're going to get that v is equal to 5.27 meters per second. The rearrangement, you would just distribute this square, calculate all the numbers, and then you're going to get like, this is, so sine 30 is a half, 2.877. Yeah, that's half of 5.77. And then you're going to get 4.985 times 5.77 squared. That's like 5 times 25. So it's basically 125, but like more, like call it around 150 estimation, divide by v squared. And then you're going to do minus like this, right? This is also negative, by the way. These are both negative terms. So you're going to do your this number minus onto this side, and then flip them around. So v squared, and then this, the two negatives divide. Then you take the square root of the number, and you get 5.27 meters per second. Okay, on to B. What is the speed of the ball when it hits the ground at B? Now, remember, this is not asking for velocity. This is asking for whatchamacallit, speed. So don't make that mistake. You want the magnitude. So we need to get Vx, and we need to get Vy, right? So that's pretty easy. We already have an equation for Vx right here. And we have Va. So Vx is equal to 5.27 cosine 30, which if you plug into your calculator, you will then get 4.56 meters per second. And we also need the time so that we can solve for Vy, because we don't have an equation for Vy. What am I talking about? Oh yeah, this is Vy at B. Sorry. We don't have an equation for Vy at B. We have one for it at A, but we don't care about A. We care about B. So we get our time using this equation, right? Specifically with Vx, by the way. This is like after simplification. So we have T is equal to D over Vx. So T is equal to 5, which is this, over 4.56, which gives us a time of 1.096 seconds, right? And finally, we just need to get our y. So we need a final velocity. We have an initial velocity. So we know our equation here to use is this one, because we have acceleration as well, and we have time. Vy is Vya is whatever it is, 5.27 sine 30, right? And then minus 9.81, T is 1.096, which gives us a nice number of negative 8.117 meters per second. That's supposed to be a negative, not an equal sign. Okay. I'm looking for speed. Speed is magnitude of v. So we're going to take magnitude of v, square root of 8.117 squared. And technically you're supposed to write the negative and like put it in brackets, but I don't want to do that. And I actually don't really ever do that. So whatever, because it doesn't matter. The square gets rid of the sign anyways. So omit the sign. Final answer of 9.31 meters per second. There you go. Also, I need to check. Is that how it works as a dot? I think it is because of the dot. Yeah, it is. Okay. Interesting. Anyways, those are all the questions for today. I hope everything was straightforward. Everything made sense. The questions are really easy. Fun questions, in my opinion. As you can see, there's not really a lot of work. You kind of like organize your units, get an equation, and then just calculate values. Like same thing here. This question, do I still have its picture? No, I deleted it. I can get it back. Yeah. No, it wasn't this one. Whatever. It was too far gone. This question was good because it shows that you can't only be thinking about numbers, right? Because in this case, you had to rearrange to get an actual way to solve for theta by eliminating t as a variable. This is basically systems of equation stuff. You have two unknowns, which is theta and t. So you need to do elimination somehow. Or, yeah, it was elimination because the t is gone now. And you get theta. We don't even need t. All right? Good questions. I hope you enjoyed the video. Have any questions, let me know. Thank you for watching. Bye.